Welcome to Math 106, Chapter 0.2, where we talk about linear functions and really get familiar with the ins and the outs of lines. So a linear function has the form f of x is equal to ax plus b, or ax plus by is equal to c. Now, different forms, different notations have different significance. And if you didn't like this particular form, you might be a little bit familiar with the other form. Now, the first equation is useful when finding your slope and your y-intercept. It is easily and usually is what's written. This is what I'm going to prefer you all to write in this form. Now, if you didn't like that form ax plus b, you could have rewritten it as f of x is equal to mx plus b. Now, what is f of x signifying? Well, f of x is just acting as a different way to say y. So these two are interchangeable. This one is just a little bit better to write. This is what I'm going to typically write in. This just allows us to show what value is being replaced when we go to evaluate. Now, we did say that there is a slope and a y-intercept. So which is which? Well, your m is your slope. This is directly attached to your x, and your y-intercept is b. This is also called your constant as well. It's called your constant because no matter what happens with your x value, this b will always remain the same. Now, it is your y-intercept, meaning that your x value is 0 and your y value will be that particular b. That is what your constant is. That no matter what change happens to your x, this value will always be the same. Now, for your slope, what's another word for slope or words? Right? A couple different words that we can use. I think you guys are most familiar with right now, rise over run. Where rise is referring to what? Rise is referring to the change used for that little triangle delta symbol in y over the change in your x value. So there's going to be some sort of change between your x's and your y's at some point on your line. Now, your second equation over here, ax plus by is equal to c, is called your general form. It's useful when finding your x and y intercepts. An intercept is where your graph touches either the x or the y axis. So that being said, and this is this general form, this ax plus by is equal to c, doesn't give you much information right off the bat. However, it is easier to find your x and y intercept in this form. The one above here, it already gives you your y-intercept, but then you need to do a little bit of work to find your x. Whereas here, it is a little bit easier to find both when written in this form. I will never have you guys write it in this form. Sometimes it starts in this form and then you transform it, but we're never going to end up in this format. So can you guys try out example 1? It says find the x and y intercept and slope. Write the equation of a line in slope-intercept form. So it wants that first one, f of x is equal to mx plus b. So I'm hoping at this stage, you guys know already how to get your response. So if you know or wrote it as y is equal to x plus 3, or you could write 1x plus 3, that's fine. You don't really need that ghost hidden one, that's fine. Or if on this one, if you have y is equal to negative 2x plus 3, you guys are good to go. Move on to the next page, skip along in this video. Now, let's say you're not at that point. Let me erase a little bit and backtrack. Well, in that format, that first format, your slope-intercept form, we said we need y equals mx plus b. B being your y-intercept and m being your slope. So your y-intercept, we just referred to as when your line touches the y-axis. Well, you have your y-axis right here, and your line is touching at 3. So your y-intercept is 0, 3. Therefore, this must be your b. So y is equal to something plus 3. We'll just use x here for significance, x. And we need to figure out, well, what is your slope? And we said plus 3 because it's a positive 3. If we were down here at -1 or -3, we could just say -3. Now, when we talk about your slope, right, we're talking about the change in your coordinates, right? So if you already had one coordinate, we already found your y, we can find another one, another coordinate. And typically we want any coordinate that touches your line in such a way where it's touching at these corners. And notice that at this one, we have your graph meeting the x-axis, meaning that this is your x-intercept. And we have lots of points to choose from. Now, it doesn't matter which one you choose. Typically, you want the next closest one. So if you go from point to point, if you're going from rise, right, all the way over to your run, well, by how much did it change? Well, we only had to rise by 1 and run by 1. And again, if we did it for one more, we rose by 1 and went over by 1. If we went, if we didn't want to do those 2 points and we wanted to skip a little bit, meaning we rose by 2 and went over by 2 to get to this point, right? 2 to 2, meaning that when we're writing it, your rise is on top, 2 divided by 2, your run, meaning that this is 1. Or if you decided to do 1 to 1, it's still 1 rise and 1 run. Or if you wanted to go all the way to your y-intercept, you have to rise by 3 and go over by 3. And it's not always going to be equal. I don't always have to go up by 3 and over by 3. It can be uneven, but no matter what, your answer is going to keep coming out to be 3 over 3, which is 1, 2 over 2, which is 1, 1 over 1, which is 1. So your slope here is going to be 1. Now it is a ghost one. You don't actually have to write that particular one. So you can just leave it as x. Or you could write m is equal to 1. Let's try it again here. Again, your y-intercept is at the coordinate 3. So when we put it into the form, you could put y is equal to, or f of x is equal to. So it's a positive 3. And now let's find your slope. So your next nice point is here. And we are trending downward. So your line is going down, not up, which means your slope is negative. So we know that this has to be a negative number. So we're going to go down by 2 and over by 1. So your rise, your slope, is 2 over 1, and it's negative to suggest that we're falling. So your slope is -2. If you want, you could write it as -2 over 1, but if there's a 1 in the denominator, you can just have it as is. Now let's look at example 2, word problems. So putting some of these linear actions into an equation. It says, suppose that a computer software company produces and sells a new security software at a cost of $55 per copy. And the company has a fixed cost of $15,000. Sorry, that should say 15. Hopefully I said 15 per month. So express the total monthly cost as a function of the number of copies sold. Find the computer cost when the numbers of copies sold is 1,000. Identify the slope and the y-intercept and graph the results. All right, so what have they defined for us? Well, it does say find the computer cost when the number of it says express the total monthly cost as a function of the number of copies sold X. So in that sentence alone, they have defined X as being the number of copies. Therefore, your Y, you could say, is C of X, which is equal to the cost, or the monthly cost. Now, what does it mean by fixed cost? Well, fixed cost financially means you're going to have this value no matter what happens. So if an electrician or a plumber or somebody comes to my house, they're going to charge me just a fee for showing up. That is going to be on top of anything that they do to my house. Same thing, it's a fixed cost, which is acting as what? If we're talking about putting this into slope-intercept form. Well, your fixed cost is going to act as your y-intercept, your b. So if I were to put this in, it's going to be $15,000. So sorry, you're going to hear a little bit of noise coming in the background. Hopefully it's not too bad. So you have $15,000 just to no matter what. Now, when it says the other part, we have $55 per copy. Well, we just said copies is going to signify X. So for each X that's produced, we're going to get hit with a $55 cost. So you have 55 as your slope, and then X as it changes. So our equation should say C of X is equal to 55X plus $15,000. Now, if we can evaluate, how much cost do we have after when we have 1,000 copies? Well, we can take your copies, or you can take your formula. We know that X is 1,000, so we can put it right into the formula. So how much do we get? Well, we get charged $70,000. So if we were to put it into words, it could say the cost of 1,000 copies is $70,000. Let's have you try our next one. It says a gas company will pay a property owner $5,000 for their right to drill on their land for natural gas and about 10 cents for each 1,000 cubic feet of gas extracted from the land. Express the amount of money the landowner will receive as a function of the amount of gas extracted from the land. Now, I'll give you a tidbit. When it does say this sentence, as a function of, what's nice is that at the beginning of as a function of, or before as a function of, this will read our y value. And at the end, or at the or following as a function of, this will refer to your x value. So your x is being defined as the gas extracted. This is thousands of cubic feet. And your y value, we're talking about, again, maybe C of X, is going to be your cost. All right, so we need to make an equation. So it says, again, once more, a gas company will pay a property owner $5,000 for the right to drill on their land. So no matter what, we get $5,000. So that is going to act as your y-intercept. And then for the gas that's extracted, for each thousands of cubic feet of gas extracted, we're going to get paid 10 cents from that natural gas. So that will act as your slope. You have your x value. So this is what your equation should come out to be. And because we know now what your equation is, we want to know how much do we get. Let's say if, let's say x is equal to 110,000. We'll just add something in there. Let's evaluate. So we can take out your calculators if needed. I don't think we need it, but in case you still have it. We have 0.10 because it's a nice number with the pen. We should have 501. So it says the cost of gas extracted for 110,000 cubic feet is $5,011. So that's what that value is right here. Again, that's kind of just been tacked on. I just wanted us to express the amount of money. So here you go. But in case you needed to do something extra. Now let's talk a little bit more about line orientation. So other lines. So we got horizontal lines. So if we're talking about a horizontal line, let's take this horizontal line. I'll draw it right here. Let's say that's my horizontal line. It's just going to continue off the page no matter what. And if we were to put this into y equals mx plus b format, right? Well, what would your slope be? Well, if we went from point to point to point, right? Point to point to point, forwards or backwards, doesn't matter, right? Are we rising at all? No, your y value is gonna stay consistent, right? Your x value can change. Maybe it goes from 0 to 1 to 2 or maybe -1, right? So your x value will change, but your y value doesn't. No change. But this one is changing. So no change we could express as 0, and we'll just say change is delta, right? But no change means that it's got to be 0, right? So 0 divided by some number, that's going to come out to be 0. So means that your slope here, y equals 0x plus b, is really just y is equal to b, your y-intercept. So sorry, you're going to hear the cat. But this is your y-intercept. So horizontal lines, what do we know about their slope? Their slope is 0. Slope is 0. And so if I said, hey, can you graph the line y is equal to 3? This is just your y-intercept. And it's not just your y-intercept. Your y value is going to be 3 no matter what. So I could draw the exact same graph, 1, 2, 3. And your y value is not going to change. This could be -1, 3. This could be 0, 3, 1, 3, 2, 3. Notice that your x value is not changing. Sorry, your y value is not changing, but your x value is. So this is y is equal to 3. So if that has a 0 slope, vertical lines must have a different slope. So let's take the same sort of graph. Now let's draw a vertical graph somewhere on this page. Okay, here's my vertical graph. Goes off my page. There we go. So let's take a look at this vertical graph. If we went from point to point to point, point to point to point, right? What is happening when it comes to your slope? Is there a change in your y coordinate? Yeah, there's a change in your y. We could see that. Okay, we were here, then we were at here, then we're over here, then we're going to go up, right? Now, is there a change in your run, your x value? There's no change. No change signifies just it's 0, and there is change, so some sort of value. Can you divide by 0? Is that possible? No, not possible. This is undefined. So when it comes to vertical lines, these are undefined. No chance of that slope. Now, when we talk about graphing, let's say graph x is equal to 2, we'll locate where x is equal to 2 on your graph. Well, that could be right here. This could be 2. I got my x-intercept here. Where else can x be equal to 2? Well, it could be also here. Maybe this is a 1, maybe that's a 2. So that could be 2, 2. This could be 1, 2. This is 0. I'm changing up my points. Looking at too many different numbers. 2, 1, 2, 0. We'll say this is 2, -1. I'll just put an extra point right here. But we're going to end up forming a vertical line. So I know it looks kind of the opposite. I know vertical, it's normally y, but really in reality, you'll notice that your x values not changing. No change. Your y value is changing, just not your x. So that's for just linear. When we talk about quadratic models, these models are used for average cost. Now, typically with the quadratic, they take on that kind of smiley face or frowny face version. So they kind of have this curve to it. So you're going to see this when we cover average cost or just quadratic models in particular. Now, rational functions, these are when your variables are located in your denominator, like we're going to see down here. These are used in environmental studies for cost-benefit models. The cost of removing pollutant from the atmosphere is an estimate as a function of the percentage of a pollutant removed. So these you'll see also in this real-life context. So you'll notice that we've already seen this once in our previous video on how to find your domain and range, but now we can figure out, well, why is your domain as such? And keep in mind, we talked about having these asymptotes, these lines where it looks like we cannot touch. So we have these asymptotes here. This is where y is equal to 0. This is where x is equal to 0. And we are not able to touch at these values. Can't touch the asymptote. So we'll behave like this. Now we said previously your domain on this, we said was going from -infinity to 0. And then we're going to skip over 0 and go to infinity. So you'll notice that your graph is nice and solid. And then as x is approaching 0, we have to jump over your x value at 0. And then we can continue on and have more x values that is represented in your domain. Now that 0 is coming directly from your equation. Because down below here, your variable, we have 1 over x. Well, with x being in the denominator, right, Are we allowed to have a number? Well, is there a number that we're not allowed to have in the denominator? Yeah, there's no 0 in the denominator. It cannot be equal to 0. And this is just a very elementary case. Eventually, you'll end up seeing where it's x plus 2, right? We can say the same thing. You just cannot have 0 in the denominator. It doesn't mean that 0 plus 2, no. If it's 0 plus 2, that's just 1 over 2. Is there a 0 in the denominator? No. What number does x have to be in order for a 0 to occur? Well, that would be a -2 plus 2. 1 over 0, not okay. So it depends on the variation that will have an issue with your denominator, your domain. So for us in this elementary case, right, if there's a 1 over 0, we just can't be equal to 0. The more complicated the rational function, the more complicated your graph in your domain is going to come as a result. All right, let's do it one more time. Let's have you guys figure out your domain. I on accident gave this one away from you, but notice that we have 1 over x plus 2. Your domain from this one, right? We can say, okay, well, we cannot have a 0 in the denominator, right? So the only number that we have to stay away from is when x is equal to -2. Now, if you don't see it right away, all you have to do is say, okay, x plus 2 is equal to 0. I'm going to subtract the 2 to the other side. Therefore, x is equal to -2. But if I put that back in to 1 over -2 plus 2, I'll get 1 over 0, which is, again, not allowed. So it just means that -2 is the number that we need to stay away from. So if we were to write your domain, and let's say this is done without your graph, we have a -2, and we have all other numbers, right? We have -3, we have -1, we have 0, all those numbers, right? Those numbers are okay. They're not going to spit out a 0. It's only if we have -2 that we are not allowed to be. So we can be any number but -2. So this is where your interval is going to come in play. So if we're looking at your domain, we're going to go from -infinity all the way to -2. We then get to say union -2 all the way to infinity, because we're going to keep going where any number that we could possibly want except for number -2. And we see that over here in your domain. If you were to see around -2, that strange behavior one more time in your graph. Let's do it one more time for C. Now your numerator is a little different from previous. Now we haven't talked about your numerator. It's because it's not quite necessary unless it matches something down below. When I mean matches, it needs to be exactly as is. So there needs to be another 2x down here for your numerator to then matter. But again, we don't need to look so much there. Instead, just as we did previously, we can say we don't want a 0. So that just means we're going to take one of these and say is equal to 0, x minus 3 is equal to 0, right? Do the same exact thing. X is equal to -2. Do the same thing over here, add 3. Now these are where the issue is going to happen, right? If I put in a -2 into my equation, negative 2 plus 2, negative 2 minus 3. So that becomes negative 4 up top. That's not an issue, but it does perform an issue down below where we then have 0 times negative 5. Right? The negative 5 is fine, but either way, it's going to be negative 4 over 0, which is very not okay. So negative 2 is a number we have to avoid. If we do it again over here, 2 times 3, that part's okay. Negative 2, oops, 3 plus 2, that's okay. Then we have 3 minus 3. So we have 6 over 5 times 0. And again, a big issue because then it becomes 6 over 0. Not okay. So we cannot be equal to negative 2 and 3. So if I were to throw this on a number line and create a domain, right? We just said that these two numbers we have to avoid. We can be any number between and any number on the other side. So negative infinity to infinity over here. If we were to write it, right, we can go all the way from negative infinity to negative 2. We then have to jump so we can do a union. Then all the numbers in between those two values, and again, jump 3 and go from 3 to infinity. And we should see that on our other counterpart. So around negative 2, we should have an asymptote. And again, we should have an asymptote at 3. And these are just vertical asymptotes. So at negative 2, and when x is equal to 3. Now on your homework, if it says the values to exclude, we're just going to be excluding. We're going to be excluding when x is equal to negative 2. And then again over here, exclude when x is equal to 2 or negative 2 and 3. So that is all about different types of lines and some of models.